Stepsters. I'm Lasya.
And I'm Kritika, and we're your trainers from Future Steps.
Today we'll be looking at chemical bonding, how atoms actually stick together. Welcome to the fascinating world of chemical bonding. Atoms join together to form everything around us, from the water we drink to the air we breathe. These bonds can hold atoms tightly or loosely, creating all the different materials in our universe. Let's explore how these tiny particles connect to building our world.
hmm So let's get started. Now, why do atoms bond? So, atoms bond because they want to achieve stability. Most atoms aim to have a full shell of electrons, and the outer shell is usually filled with, or supposed to be filled with, 8 electrons for them to be able to achieve that stability, which makes them stable and happy. And then think of bonding like making friends. Atoms connect with each other to feel complete. By sharing or exchanging electrons, they can fill their outer shells and become more stable. For example, if there are two atoms, one of them has 7 electrons in their outer shell and the other only has one, the one that has just one on their outer shell can bond with the other and give its electrons to the other atom so that now the other one has a full outer shell, and so does this one. And you're probably like, oh, well, the one that just gave their electron, they don't have 8, but they still do have a full outer shell, so they're still going to be considered stable. Now, atoms with incomplete outer shells are unstable and reactive. Through bonding, they achieve a more stable electron arrangement. And that's the whole point of why atoms bond. So, a very important key detail.
Now let's look at types of different bonds. The first one is the ionic bond. This is giving and taking electrons. So we have three different types in the ionic bonds too. You have metal meeting non-metal. So ionic bonds form between metals like sodium and non-metals like chlorine. So metals tend to give away electrons while non-metals want to take them from the metals. And then we have the electron transfer. So the metal atoms give one or more electrons to the non-metal atoms. Like Kritika explained before, if let's say we have 7 electrons in the outer shell of a non-metal atom and one electron in the outer shell of a metal atom, then both of them are attracted to each other and they share the electrons to make them stable and not unstable and reactive like they were before. This creates a positive ion, cation, okay? How I remember this is cats have paws and that's positive. So remember it that way. So positive ions are known as cations and a negative ion is an anion. So positive ion are like when they balance each other out and there's equal amount of electrons in the atom itself. That's a positive ion, and a negative ion is the opposite of that, and it's called an anion. And then we have attraction forms. The positive and negative ions attract each other strongly, forming an ionic compound like the table salt NaCl. So we always know the positive and negative attract each other, and hence when they like attract each other, they form a compound. And if it's a metal and a non-metal attracting each other, it's going to be an ionic compound. And an example is salt.
Mhm. Now let's talk about covalent bonds. These are bonds that require sharing of electrons. So there are 3 main types of these bonds. There are single bonds, double bonds, and triple bonds. So single bonds are when atoms share one pair of electrons. For example, in hydrogen gas, a hydrogen shares one electron pair. And a pair means 2 electrons, so that That what that means is basically it's going to look somewhat like, let's say we have two hydrogens, right? And this is their bond. When it says electron pair, it means there's one electron connecting to the H over here, and the other electron from this H connecting over here. And we know that H's only have one electron, so that is how the hydrogen single bond looks like. And then the double bond is basically the same thing, but now they're sharing two pairs of electrons instead of just one. That's why we have two lines instead of one line. And the triple bond, as you could have guessed, is when they share three pairs of electrons. So now it's going to be three lines. For example, nitrogen. Now, covalent bonds, form primarily between nonmetals. Instead of giving or taking electrons, atoms share electrons to fill their outer shells. And I did also talk about this before, so I'm pretty sure you guys have a decent idea of what we're getting to right now. And water is a perfect example because oxygen shares electrons with two hydrogens, and that's just two single bonds. So that water is probably the one example for everything because, well, not everything, but it's a very common example that works with a lot of things.
So now we're gonna look at hydrogen bonds. So these are weak but important attractions. So bonds aren't true chemical bonds, but are special attractions between molecules. They form when hydrogen is bonded to highly electronegative atoms like oxygen, nitrogen, or fluorine. These bonds explain why water forms droplets, ice floats on water, and how DNA forms its famous double helix shape. Hydrogen bonds, in this picture, they're shown as dotted lines, like in this slide, dotted lines attached. They help water molecules stick together, creating surface tension strong enough for some insects to walk on water. So if you ever seen a small insect walk on water, that's because of hydrogen bonds and how they're weak, but they also help water molecules to stick together and helping create a surface tension so that small insects that are really lightweighted can walk on water.
Hmm. So kids, please do not try walking on water. It will not work as that's not how gravity works. Now we're going to talk about metallic bonds, electrons moving freely. So me metallic bonds have different characteristics. One of them would be electrical conductivity. This is basically free moving electrons allow metals to conduct electricity, making them perfect for wires and electronic components. And we've probably noticed this in a lot of things. So notice how your car is made of metal, because it can conduct electricity. And a cool example of that is think of when you're driving and it's raining, let's say there's like a thunderstorm, and you, the reason why your car is made of metal is because metal can conduct electricity. So if lightning strikes your car, it's unlikely of you to get hurt. Though your car is probably going to stop working, but you will be safe because all of the electricity is going to be gone with with the metal because the metal can conduct electricity. And later on in physics, you're going to learn exactly why that happens. But you don't need that right now. It's not in your syllabus, so I'm not going to go that much in depth. Now, the other characteristic is malleability. Metals can be hammered into sheets because their atoms can slide past each other while staying bonded. And that is a really cool thing because a lot of things nowadays are made of metals. And almost if you ever go into a factory where, let's say, they're making cars, because I just love cars, you can say that. And you're probably gonna see the metal frame of the car being hammered, and if you ever end up digging up any metal, it's not gonna look like a a nice cube. It's probably gonna look like a rock. And that rock is then melted and then you can just like crush it into whatever shape you want. It's not easy though. And then the third characteristic is heat conduction. The sea of electrons quickly transfer thermal energy throughout the metal. So metals can't only conduct electricity, but they can also conduct heat, which is also really cool because, but then at the same time, it's not, I wouldn't say it's the best, but I think the electrical conductivity is the coolest one of these. Now, in metallic bonds, metal, metal atoms arrange in a lattice and share their outer electrons. And they share their outer electrons in a sea that flows freely around the positive metal ions, and this explains why metals have these unique properties. I'm pretty sure a lot of you guys are probably looking at the screen and going, what do you mean by that? That is basically metals have electrons moving freely they in a way that it helps it do all of these things we just talked about. So that was it for metallic bonds.
Now let's see how we can visualize bonds using Lewis dot structures. So Lewis dot structures are simple joins that help us visualize how atom bonds. Dot represents the valence electrons, so the outer shell electrons, and the line shows shared electron pairs. So um, let's say for water, for example, this in here we have oxygen sharing electrons with two hydrogen atoms, forming two single bonds. So basically, it's similar to this diagram, but I'll make it in a simpler way. So we have one this I think we did another video in our channel. There's another video that talks more in depth about like I also drew water and I talked about how the electrons share each other to make water itself. And you can look at that video too. But for now, let's look at these examples we have here. We have H2O. So what the two stands for is that there's two hydrogens. So just draw two circles. And then we have one, there's nothing at the bottom of oxygen. So that just means there's one. So that's one oxygen right here. So let's just label them. That's O, and this is H, and that's H too. And then we have them sharing electrons with one another, forming two single bonds. So what do they mean by that? It's just basically that. So there's two bonds, but they're single bonds, right? There's not like two bonds here and two bonds there. It's just single bonds. And that's how you do oxygen, because the hydrogen, two hydrogens share their electrons with oxygen to make this whole compound stable. And that's how you get water. Let's move on to the second example. We have carbon dioxide. So in this case, we have C, which is one, right? There's nothing at the bottom of it. So just draw one carbon atom. And then we have O2. This time we have two oxygen atoms. So just draw two circles and label them O because they're oxygen. And then we have carbon forms double bonds with two oxygen atoms. So what this basically means is double bonds. Remember, Kritika was talking about before? We have double bonds, which means we have two strands attaching the oxygens with the carbon. And that makes a stable compound known as carbon dioxide. Let's look at the last example. We have methane, which is CH4. Okay, there's nothing at the bottom of C. There's just one C particle atom. And then we have four H's. So let me draw one here, 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 and then there. Um, hold on. Okay, yeah, there we go. Okay, and then label them all H. I'm just gonna do one because it's taking time, but just make sure you're labeling everything. And then we have carbon shares electrons with four hydrogen atoms. So just single strands with every one of them. So even it's just not two particles with one particle like you saw in this example. You can have many other atoms surrounded by one atom, or you can have two atoms surrounding by five atoms. It's possible. It just depends on the compound itself and how many atoms, electrons they share with one another to make them stable. And also, if you remember these, you get better at Lewis dot structures the more you practice them. So go ahead and like go to Google and just search up for some examples and try practicing them. And make sure to comment down below if you have any other questions on these structures and if you have more doubts on how to actually draw them.
Mhm. And I would also like to add on a small thing. So while you're drawing these, there are also these dots that you have to show. So okay, I can't draw with that. We're gonna say that's a circle. And this is our oxygen, right? And then we have our two hydrogens for the first water example. We have single bonds, and then you would notice that the single bonds are a little bent to the bottom. That is because notice how it says dots represent valence electrons, which are the outer shell electrons. And how do I know how many valence electrons the oxygen has? Is because if you go to the periodic table, it depends on which group that that element is in. So oxygen is in group 4, so it has 4 valence electrons. So we're going to have 4 dots. And they would look somewhat like this because dots are usually in pairs. So we have two pairs. And you would just follow that for everything else too. I'm just drawing that for one, but carbon is also going to be in group 4. So you're also going to have, wait, yeah, you're also going to have 4 valence electrons, and then methane should be the same too. And if you want, you could just go up to Google and, like Glacius said, try searching up some examples, trying it yourself, and checking with, the Google response that it gives you. And that would be good practice for this because a lot of people mess up those dot structures. Now we have a home experiment. This is called the salt crystal growth. And this is going to show you how ionic bonds work. So let's talk about the steps. Step 1. Mix 1/4 cup of table salt with half a cup of very warm water in a clear glass. Stir until completely dissolved. Step 2. Pour the solution onto a flat plate or shallow dish. Place it somewhere it won't be disturbed. So if you have siblings, make sure it's hidden. Now, step 3. Check check daily and watch as water evaporates and cubic salt crystals begin to form. Use a magnifying glass if available. If not, you could probably just try zooming in with your phone's camera too. Now, the salt crystals form because sodium and chloride ions arrange themselves in a regular pattern as water evaporates, showing how ionic bonds are working.
This is another experiment you can do at home to look at hydrogen bonds, and it's called water surface tension. So firstly, fill a glass. So fill a glass with water up to the very brim, being careful not to spill any water. And add pepper. So sprinkle some ground pepper or maybe any powder you have or paper clips gently on the surface of the water. Make sure to be gentle. And then lastly, add dish soap. So touch the wall. Oh, so like take some dish soap into your hand or maybe like an earbud anything like that, and then touch the water surface with the toothpick or earbud or your finger dipped in dish soap and watch what happens. So it's this experiment is really cool and I tried it before and I enjoyed it a lot. So comment down below how much you like this experiment and what actually happened to the ground pepper sprinkled on the top when you actually put a dish soap um like a toothpick or your finger or anything dipped in dish soap on top of it. Comment down below what you've seen. And the pepper floats because of the hydrogen bonds creating surface tension. And soap breaks these bonds, causing the pepper to scatter away quickly to the edges. I think that was revealed here, but like make sure to try it out. It's really fun. And because like every single time you touch on top of the pepper, it just disperses and goes to the edges. So it's really cool to look at. And basically, this happens because of hydrogen bonds creating the surface tension in water.
It's also a really simple and cool experiment that you can do without making a huge mess. So your parents will be happy too. So it's a win-win. Try it. Now let's get into our summary. Bonds build our world. Let's talk about, so we talked about a lot of things, and this is just a short list of what we talked about, probably the most important part of our video. We have, we talked about ionic bonds, where electrons transfer between metals and nonmetals, which creates charged ions that attract each other. So we talked about anions and cations. And like Lasia said, you can think about cations as cats have paws, so it's positive. I really love that example. And it's a really easy way to remember it too. So that is how you can remember. And then you know that anion is the complete opposite, so you'll probably know. And then for covalent bonds, we talk about how atoms share electrons to achieve stability, forming molecules like water and carbon dioxide. And then we talked about metallic bonds, which which are shared electrons C around positive metal ions give metals their special properties, which is a really complicated definition, and I told you a simpler way would just be to know that all of these electrons in, let's say, a sea of electrons are built around these positive metal ions, which help these metals, have these characteristics. And I also gave you a couple of examples of the characteristics, which were pretty cool to me at least. And then we talked about hydrogen bonds, which are weak attractions that are crucial for water's unique properties and biological structures. We also talked about an experiment that you can do to see this, which is pretty cool and you should try it definitely. Now, chemical bonds are the invisible forces that hold our world together. By understanding how atoms connect, we can explain the properties of everything from salt crystals to water droplets. Keep experimenting to see these amazing bonds in action. So definitely try the two experiments we gave you. If you want, you can search up more experiments and do them as well. And remember to always have an adult if if the experiments require something that needs that needs fire, something that has warm substances, or something that you are not sure how to do, you can always call over one of your parents or an adult to supervise you. So that is all we have for you today. Comment down below if you have any questions, concerns, video requests, or any comments at all. We do look at all of your comments, so don't think you're going to be left out there in the comment section alone. You're not. We will definitely look at it and we will respond. So that is all we have for you today. See you in our next video then. Goodbye.
Bye, Stepsters.